All right, welcome back. This video will look at molar mass and figure out the molar masses of compounds used in chemistry. We'll take a look at how we can, in fact, do that. So, of course, this takes us back to the good old mole conversion chart. So 1 mole represents 6.02 times 10 to the 23rd things, atoms, particles, etc. And, of course, what happens when we take that many of a particular atom, let's just say carbon. So if we look at our periodic table of relative masses or atomic mass units, we know, of course, hydrogen is assigned a value of 1 for 1 atom of hydrogen, and a carbon atom is assigned a value of 12. Now, that tells us basically that a carbon atom is 12 times bigger than a hydrogen. Now, it'd be nice if, of course, we could have these in terms of grams. To do that, if we had not 1 carbon, not 2 carbons, not a million, but if we had 6.02 times 10 to the 23rd carbon atoms and threw them on a balance, they would have a mass of 12.011 Gs. Same thing with hydrogen. If I had 6.02 times 10 to the 23rd atoms of hydrogen, threw it on a balance, it'd say 1.08 grams. So that number there represents how many atoms we would need to have to turn these numbers, these relative mass numbers, to grams. One for zinc, 6.02 times 10 to the 23rd. If I had that many zinc atoms, threw them on the balance, it would say 65.39 grams. So that's all we're going to be doing with this. So for example, if we take a look at potassium phosphate, and if we're figuring out molar mass, we're looking at the mass of 1 mole. Mass of 1 mole of substance. That's really what it means, finding the molar mass. So I'm going to go on a different piece of paper here. So if we were looking at potassium phosphate, so K3PO4, and if we were figuring out the molar mass, if you recall from physical science, quite often what we do is we put a big M in front of that, and that big M means figuring out the molar mass of that. Now, if I had 1 mole of potassium phosphate, for every 1 mole of this, I would have 3 moles of potassium and 1 mole of phosphorus and 4 moles of oxygen. So all we need to do is look up those values on the periodic table. So potassium, 39.098, I can round that up to 39.10. And phosphorus, 30.97. And good old oxygen, 15.99999. Just round it off to 16.00. And there we have it. So we could just simply calculate that and see what we get. So if you see here, 3 times 39.1, that gives us 117.3. And that's 30.97. And 4 times 16, that's 3264. Then, of course, adding those all up, we get 212.27, and the unit we use there is grams per every mole. That's it. That's how you figure out the molar mass. If I look at another one here, if I look at, let's see here, how about antimony nitrate? So SB, NO3, and that's all 3. So I figure out the big molar mass of that. So I need to look these up. So SB, antimony there is 121.76. Oh, let's write this out first. Now over here, so the reason why I did this one is you can see here we have 3 of these nitrate groups. So that means I have 3 nitrogens. And then 3 groups of 3 oxygens. That's a total of 9 oxygens. So it's 9 times 16. And nitrogen there is 14.007. We can round that off to be 14.01. And SB, antimony 121.76. So 1 times that, 121.76. Okay, and then over here we have 42.03. And 9 times 16, 144, you bet. Then add those all up. And we get, oops, what do I get? 307. 307.79 grams per mole. I'm just going to check that. That number seems big, but hey, we have some big numbers here. Yeah, 307.79 grams per mole. So there we go. So you can do some of those on that sheet, and you should be in okay shape for figuring out molar mass. Then, of course, the next step with that, we can do some mole calculations, either going from mass to moles or moles back to mass. All right, we'll see you again.